welcome for this FireMonkey 3D programming session. So it's going to be a very camered session. So if you have any questions, feel free to stop me. So idea for the session is to actually go through the basics of creating 3D applications with FireMonkey. So with FireMonkey, you can create applications that are using low-level APIs of different platforms. So, for example, when we have a FireMonkey 3D application compiled for Windows, we are using a different 3D API, a DirectX. And when we have the same application compiled for Mac, in fact, we are using a different API, which is an OpenGL. And the same application in the upcoming mobile compilers will be using a different API, OpenGL ES. So this is really a great thing in terms of the productivity, because normally when you want to create graphics applications, you have to be quite fluent with different APIs. So, for example, when you create an OpenGL application, then it's actually quite involving in terms of mathematics. You have to write different shader programs, so it's not that easy. So FireMonkey does a great job of actually hiding this complexity from the programmer. So we as programmers, we can use either Delphi or C++ language, use high-level types that FireMonkey provides, and at the bottom the FireMonkey will talk to the correct 3D API. So we don't have to worry about it. So in fact, on the next slide, actually, in graphical applications that we create, typically we don't have this framework here. So typically you just create an application, and if you want to create a 3D graphics, you want to basically use a 3D API, depending on the platform, can be OpenGL and Direct 3D. And with these APIs, you basically talk to the graphical processor unit that is actually responsible for rendering. So this is actually a graphics pipeline that is typical for contemporary GPUs. So we have a programmable so-called shader processors. So this is pieces of code that are being executed natively on a GPU. So this FireMonkey sits in between the actual 3D API, the low-level API, and your application code. So you don't have to think in terms of these low-level APIs, but the FireMonkey provides you with the abstraction. So you basically code against the FireMonkey, and the FireMonkey is taking care of the rest. So this is the big picture, and in terms of FireMonkey, that's a very big deal, because you don't have to worry about the different low-level stuff. So I'm going to start through with a little demo that actually compares the complexity that you need to do in a raw OpenGL programming and with FireMonkey. So I'm going to actually switch to this guy. Okay, so I hope you can hear me, or maybe not. Okay, that's better. So I have free hands, and I'm going to, first of all, maybe it's going to look strange, but I'm going to start Xcode, and just to show you the comparison, what it takes to create an application in a pure OpenGL, and what it takes to create the same application using FireMonkey and high-level projects. So here we have actually, if I want to create a new project in Xcode, there are a number of different templates, and one of the templates that I'm going to use is OpenGL game template. So basically, I can just click on next, have all the product name my demo 1, click on next. It doesn't really matter what it is, but I can just load it. And I'm just going to show you what kind of the complexity you have when creating this on a quite low level. So first of all, you have to be, maybe let's have a look what this application does. So if I run it
from here, it will start an iPad simulator, and this is the resulting application that is basically a starting point for doing OpenGL on a quite low level. So in a moment you should see two cubes. So this is really just a starting point for building a 3D applications in a traditional way without using FireMonkey. So I'm going to actually stop it if I'm actually in a proper resolution. So basically what you see here is this quite a lot of mathematics involved. So actually the main view controller, actually you have basically the definitions in terms of the positions, vertex buffer that defines different points that makes up these two cubes, and you have to pass it to the graphical card and basically call some OpenGL APIs, and you do all the mathematics here with a quite low level code. So let's have a look what it takes to create a similar application without going into this mathematics and without actually understanding, without writing the shader program. So this is actually, you can hardly see it from the from the back, but this basically, when you want to create applications in a non-FireMonkey way, you have to go quite low level. You have to understand shader programming, you have to understand mathematics in a quite low level. So let's now actually go ahead and try to do the same thing using Delphi. So I'm going to create this same application from scratch. So with this I'm going to create a file new, and with file new you have different options. So basically you can, in fact I could create this application with either C++ Builder or Delphi. It doesn't really matter because I'm not going to write any line of code. It's only going to be some components. So I'm going to go for a Delphi project, and here when you create the FireMonkey desktop application, I have a choice whether it's going to be HD or 3D application. So this is also important for the 3D programming, that you can easily mix HD with 3D. So this choice here is basically only the initial form, whether it's a 2D form or a form 3D, but then I could actually go with HD and to put in a viewport component and use 3D graphics. And I can also go for a 3D, and I can also use layer 3D component to use a traditional two-dimensional components. I'm going to go for a 3D application here. So right now what you see here is a three-dimensional view. So this empty form, on this empty form you can use different components that comes with FireMonkey. So basically what I can do is use things like shapes and the different basic components like camera, light, dummy on proxy, and different predefined shapes. So I'm going to actually use two cubes, but then I'm going to first start with some lights. So I'm going to add one light to this screen and maybe more light, so it's nicer. So actually what is very important in FireMonkey, and you can see it, that is a concept of parenting. So it's very important to understand which component contains other components, because all the contained components are inheriting all the transformations from the parent component. So in this case, when I want to have these two cubes that are rotating against the same axis, I want to actually use a non-visual component called dummy. And dummy is a very flexible component that you can use just for organizing other components. So, for example, if I want now to make these two cubes rotating against each other, I want to add these two cubes that I'm in a moment to this dummy component. So they will be connected together, and I will be able to just manipulate the dummy component, and all inherited components will be going with it. So it's Also in a HD applications there is a similar T layout component that is non-visual and is just used for grouping. So I can here actually start adding some shapes. So I'm going to add one cube. So notice that is added to the dummy and also the second cube. So I'm going to make sure that they are first owned by the dummy. Also, what is important is that I can now use a camera. So I can either use a camera explicitly, or there is also a built-in camera in a form 3D. So if I don't explicitly add a camera to the form, it will be still displayed. So to keep this example simple, I'm not going to add camera just to make it as easy as possible. So I'm going to change maybe the background of this form to something more interesting. Maybe let's make it teal. And also I can now actually move these two cubes so they are not in the same place. So I'm going to actually change the position of the first cube to something like -1 or maybe -1.5. It's also important that it's all float values. So you can actually use like not necessarily has to be an integral value. So I have now two cubes that are not exactly in the same place. And also what is new in XE3 is the brand new material system. So now in XE2, when you want to change the color of the shape, there was a property called material that you could change, but then it was not very effective because every shape had its own material. Now this has been changed and redesigned. So if you want to add some colors or some use materials in a 3D objects, you have to actually add a separate component. So in this case it's called light material source. So I want to have two of them. So I have one for one cube and one for another. So I'm going to change the color of this first one so it's more similar to what we saw on this previous example, and maybe this other one will be something like I don't know, sky blue. And now I can just connect this. Every 3D component will have this material source property that you can use to hook in a different material. So in this case I'm going to connect two different materials. Maybe these lights are not exactly where I would like them to be, so I can actually, you can see that at design time is actually changing the lighting. So you can actually see that I can now actually maybe move it not exactly like I wanted. So if it does not work, oh, that's going to be nicer. So at that time I have just an empty application, so it does not move or do anything, but I can actually run it to see what will be the effect. So yeah, just two cubes, but they are not doing anything. So first of all, let's make them a little bit bigger. So every 3D component, including dummy, has properties like position, so that's quite obvious, but also scale. So if I change the properties of this dummy component, all contained components will inherit these changes. So I want to make this whole thing bigger, so I'm going to select dummy and change its scale to something like 3, 3, and 3. So now we have a slightly bigger thing. And the second thing is that I want this to be rotating. So in FireMonkey we have these great animation components. So if I want these to first be turning, I need to add an animation, a float animation component to the dummy. So now notice that again this animation is belonging to the dummy. So I can actually now, when I open the property name, I can see all the properties of the contained component that are of type float, and I can just specify using the new RTTI what I want to change. So for example, I want to change the rotation angle. So this is the property rotation angle Y. So in this way we are going to have this rotation in this way. And I need to change some of the functionality here. So I'm going to make this duration of this rotation to 4 seconds. I want to make sure that it's enabled, that it's looped, and also I need to change the start value and stop value to something like 360. So if everything is correct, I should get to the point that my two cubes are actually now rotating against the same axis. So I'm now rotating the dummy component. But in the original application, there was also these cubes themselves were rotating as well. So that's very easy. So basically, I just need to add some more animations to achieve this effect. So I'm going to add 2 float animations because I'm going to combine the movement around the X axis with the movement around the Y axis. So I have this rotating thing. So let me actually add 2 animations to each cube. Float animation and another float animation. What I'm going to do is because they are all going to have almost the same properties, so I'm going to select them at the same time so I have less coding. So I make it duration to 4 as well, enabled to true, loop to true, and again stop value to 360. But this animation will have a different property. So one property that will be a rotation angle X, and the second one will be a rotation angle Y. And now for the first one as well, so I have to do an enabled, do a loop, do stop value to 360, and it has to be duration to 4, a loop, enabled, everything is okay. So now I can actually now select different properties. So I'm rotation angle X, and for the second one, rotation angle Y. Okay, so in this moment, I should get to the point that I'm actually got the same application that was created with Objective-C in this case, but I have a number of benefits here. So first of all, this application will run on both platforms. So I can now compile this application to Mac, and I will have one version that is using on Windows DirectX, and on Mac using OpenGL as a graphics engine. So that's the first benefit. Second benefit is that I don't have to worry about about this high-level objects. So instead of just creating in code the definition of the geometry of these cubes, these components are reusable, so they actually contain the geometry itself. And another benefit that is actually even more interesting is that you can actually click on them. So those 3D objects that we are using in 3D space, you can interact with it. So in the OpenGL example in the Objective-C, you have only the visualization, but you don't have a possibility to actually do something with it. You have to actually start writing program to maybe intercept touch messages. But here, all those 3D objects, they will have their own properties and events, so you can actually do something when you double click on a 3D object and so on. So I have actually created an other example as well, but here I actually, a moment ago, I was actually not this one, I was playing with some other things. So I have this little demo that actually demonstrates a little bit more about what you can do with 3D. So this is actually a demo that I created in XE2, and when I open this demo from XE2, the XE3 is clever enough that it will automatically convert the old material model to the new material model. So in the past, because I have here, maybe I show you what this is actually doing. So there are some errors. Okay, what errors there are? Okay, yeah, that's something that I was doing to demonstrate this, but I have to do a different project. So that's a structure, which is quite small resolution, So you can see on this example the hierarchy of different types. So I want to actually collapse this guy, maybe even hide it. So at the bottom you have a T-Control3D class, which basically all 3D components are inheriting from it, and it gives you a possibility to interact with things. So the abstract 3D object that has an on-click events, and then you have the whole hierarchy. So quite a low level is a stroke cube and grid 3D. So these are very lightweight components that does not have any geometry assigned to it. They are just being drawn. So the stroke cube and grid 3D, I can actually show you on this example here, are quite lightweight, and you can easily work with it without worrying that you will get problems with performance. So in this example, I'm actually using those components. So here you can see that was actually I'm working on a molecule viewer application. So that was, I couldn't actually get to the point that I can rescale the cylinder that connects two different molecules. I have so basically when you do it, you start from a cylinder, and then you have to actually change its height, change its width, so it's actually quite thick. But then how to programmatically make it that it actually connects to two arbitrary places in space. So basically what I did here is I'm using this high level, actually this low level components. So you have a grid 3D, so there are three grids 3D here, and also this stroke cube. So the stroke cube is just a three-dimensional cube, and this is very lightweight. So basically, if you go into the implementation of this, you will see. Maybe let's go and see the T stroke cube. That actually will get us to the is derived from T control, and you can see that basically if you have this render method, it will actually need to go like this. You have these things called context. So context in FireMonkey is an abstraction that actually hides the underlying 3D API that you are using. So this is like one object, and if you are on Windows, the context is implemented with calls to the DirectX, and when you are on Mac, the same context is actually implemented using OpenGL code. So this is actually the abstraction that lets you write a cross-platform code. So in this case, you can see that the stroke cube render is just a draw cube, and you basically just specify the types, or actually the positions of the corners of the cube. So also what is interesting in XE3, if I go to the declaration of the vector, there were some refactorings done with a basic 3D types that we are using in FireMonkey. So in XE2, things like vector 3D, point 3D, matrix were part of the FMX library, and now it has been moved to the system.types, so they can be easily used also in VCL applications if you want to manipulate and do some calculations based on 3D. Another nice thing here is that those different types, they got quite a lot of functionality in terms of the operator overloads. So you can see that this are the system types. I'm looking for the T vector 3D because that's what is the most interesting for me right now. So this is actually T vector. So you can see that those this is just a two-dimensional vector, and you see there are different operator overloads. So you can write a very nice code. So you can do like a vectors A plus B and so on. So here actually in my application you can see that I'm using these operator overloads to change the camera position. So when I do a mouse wheel or on this Mac with 2 fingers, I can actually zoom in and out. And when I was porting this application from XE2, instead of this plus sign that you can just use in your code to add vectors, there was a special vector-free add method, and now it's much more elegant. Actually, this example that I'm showing here is a quite typical scenario how you can have an interactive 3D view. So basically the idea is that you want to be able, when you move the mouse, so let me run this again, when you move the mouse, you want to have this functionality of being able to rotate the view, and also like this. So actually there are 2 ways. So one possibility is to rotate the model itself, so then you will get the same result. Another possibility is to change the position of the camera and not touch the model. In fact, you can combine both, and you could have a model moving and camera moving, but maybe it's not optimal. And you can see quite a lot within different implementation. This actually standard that you have 3 different, actually there is only 1 camera, but this camera is contained with 2 other dummy objects. So we have a three-dimensional possibility. So if the camera Y is just a dummy object, but you have a movement in 1 axis, it contains camera X, which gives you another axis of movement, and you have the real camera is actually the camera component. So also when you use a camera component, by default it will be located in the 0, 0, -5. So basically we are just looking into the Z vector. Actually this demo actually shows this quite well. So you can see that we are now looking into the Z, which is actually the, if I make it bigger, you can see that this little blue thing is actually the Z vector going into the screen. The red vector is an X axis, and the Y is actually going down. So in this way, you can actually see that how I can now both move this, but also when I was playing with it, I have these little buttons here at the side are here to actually manipulate this cylinder. So all those components, and this is the beauty of FireMonkey 3D, they are just components with properties you can manipulate in a very straightforward way without really even understanding the underlying geometry and all the vertices that you have. Eventually the FireMonkey needs to pass into the GPU. So you can see actually I'm using different material sources, and the source code is quite typical, so you will see this quite a lot. So it's just very straightforward. So if I make a mouse down, I need to remember where I am. So I just have a private field on a form down, which actually remembers the position that I made down. And then when the mouse move is detected, and at the same time I'm still pressing it, so the left button is there, then I can change the rotation angle X and Y depending on this position. So you will see this is used quite a lot in different examples. So this is one of the possibilities, is to actually move the camera. But also what is possible is to actually not move camera, but rather move the objects there. So another demo that I actually created with XE2 and now ported to XE3 is a traditional meteors demo. So how many of you remember the Windows 3.1 and the Starfield simulation Starfield simulation screensaver. So I was basically playing and trying to achieve the same result, but with FireMonkey. So again, I want to have this functionality that I can actually see that I'm in the middle of the star field and I'm actually moving into the field. Yeah? But at the same time, the other possibility is to actually keep the camera static, but change the position of all the objects inside of your view. So this is quite simple example, and you can actually see that it's not a lot of programming. Maybe first I'm going to show you how it looks like, that you are convinced that this is a real Starfield simulation, and it can run on both Windows and also on Mac. And how this is implemented, you can actually see that these are real spheres, and that I'm actually maybe you can see it in the source code. I have a timer that is actually set to 20 milliseconds. So I have an interval of 20 milliseconds. So this means that I'm updating the view 50 times per second. And in the on timer event, basically I'm changing the position of every control 3D by a certain delta value. So in this demo, I can change the number of stars that I have in my star field. I can change this amount, so how quickly they go every 20 seconds. And also I have this max X and max Y and my max Z. So this basically represents a 3D space, which is the boundary where I'm randomly placing those stars. So in the onCreate event, basically what I do here is just do a loop for as many stars as there are defined in a star count, and I'm programmatically creating a sphere and making sure that it's actually contained by dummy. So this is also quite interesting in FireMonkey. So you can specify the owner in the constructor. So this is quite straightforward. I have also a material source, so there is one light material source defined, so I need to connect it. And also I have this function random location. So this random location is quite straightforward. Basically returns a point 3D, which is the X and Y is actually in a certain area, and Z is actually into the screen. So it's from 0 to 500 and both. So basically what we are seeing is just a cube in a 3D space when there are different spheres, and basically every 50 times a second I'm going iterating through all the children of dummy, because I know that all the spheres are actually owned by the dummy, and basically I just go through it. So in FireMonkey, is actually the children are of FMX object. So this is the base class for every FireMonkey component. So first I need to retrieve just a reference to this object, but then I can actually I know that this is not an FMX object but control 3D. So if this is really the case, so I'm checking the actual type, and and then I can basically typecast to a control 3D, so I have access to the position property. So this is quite generic code, so it not necessarily needs to be spheres. Basically I could generate arbitrary cubes, spheres, anything that is derived from T-control 3D, and that would work with a normal way. So just an example of being able to actually very easily achieve results with FireMonkey, that you can just do some few lines of code and you have an application that can be compiled also for Mac. Maybe that's a good idea to compile it for Mac, but it will be just the same thing but on Mac, so maybe I just skip it. So there are also other possibilities. So for example, one of the most interesting components there is a component for loading arbitrary 3D shapes. So we have those components here for creating things like 3D shapes. So I have a plane, cube, mesh, sphere, and so on. But there's also this component called TModel3D. So this component makes it easy to import geometric information from a third-party tool. So for example, I can have a environment like 3D Studio Max or Blender or any other typical tool for creating 3D models, and then you can export this information from a 3D modeling tool to a certain file formats. So in FireMonkey we are supporting 3 different file formats, so you can basically use this model 3D component and load into the I have this dummy. Let me see where I have this model 3D dummy X, Y, main camera, and I think there is somewhere this model 3D. Okay, where it is. So model 3D is somewhere here. So I'm looking for the, maybe I just do it Control F, model 3D. Okay, so pre-model. So this is my model 3D. There are actually two models, because let me actually run this application. So we have here one viewport where I have a preview of the model, and also I have this same model displayed on a big screen where I can actually reposition it. So let me run this demo just to show you what are the possibilities here. So here I have a possibility to select a file with a 3D information. So I have different. I was actually playing with doing a new generation of this master application, when you have a scuba gear that you can buy in the shop. So my idea is not finished yet, is to actually add a preview of different scuba gear in the form of a 3D models that you can actually preview. But I'm not near that. But this is actually one of the files that I actually exported to the DAE format, which is just a scuba mask. So you can actually open this guy, and in a moment, it takes a little bit of time, because this file can be quite big, and that's something for the OmniThread library probably to see. So now actually I was able to load a 3D model of a scuba mask. So this is actually quite powerful, because you are not restricted to the components that are built in. You can create arbitrary 3D structures, and using a model 3D component you can actually load it from file. And also what you can do is edit the material. So this is actually showing different types of materials. So I have this light material, is quite straightforward, but it's very easy to actually use a texture material. So I can actually select an arbitrary texture, and when I close it, actually it's not very doing a lot. So I wonder why it's not showing what probably is just a part of it. Texture material, and I need to have this texture, and so sometimes it works, sometimes it does not. I don't know why it does not load this texture, but you can also add to those 3D models arbitrary textures, so this does not have to be that boring. So you can actually see here quite a lot of code that you can do. So you can see the same functionality for rotation that you have seen in the previous example. It's actually used quite a lot, and you have this code for loading data. So these are the 3 different file formats that are supported, and you can basically just load a model from file. So load from file, and then also what is interesting is to use some of the RTTI information. Let me actually show it here. So you can actually work with this quite in a straightforward way. So this is this designer that actually changes the material, and yeah, so this is again, you can see that we have a list of meshes. So this is actually a base class for anything that has a 3D information in the forms of the vertex and vertices buffer. Okay, so actually another thing that I wanted to show you is that it's very much like with like in Delphi, you typically would like to use a VCL and do high-level stuff. But if you want to add maybe some little bit of code in assembler or do something low-level, there is nothing that stops you. And here there is an example of actually doing this on a low level. So this is actually going back to the same example that I was starting this presentation from. You also can do the 3D programming in a low level, very much like you have to do in OpenGL. So this is the equivalent where I'm actually working on a low level. So here I basically create a vertex buffer, just specifying a number of vertices. I have my own material created. It's actually defined in the another unit here. So let me actually go to this unit like this. Okay, so I have my material unit. So here you basically can specify the shader code that is being executed inside of the graphical processor unit. But this is, again, it's quite low level and maybe you don't want to do it. But this is how you would do it in a low level. You have this context method or context parameter that basically encapsulates the underlying context being either DirectX or OpenGL. And you have a number of different methods. For example, you can draw triangles, you can change the state, you can change the rotation matrix. So this is actually a demo that demonstrates that you can, you are free to decide whether you want to go low level, and you can embed in your source code the actual shaders. But in most cases, you don't want to go low level. You can use high level components to work with it. Actually, I have another demo. That's actually one of the last demos that I'm planning to show you. It's a demo that I'm working on for chemical molecule visualization. So there is a special file format for exchanging information about the chemical molecules. It's a PDB format for the protein data bank. And here in this application, I'm actually using high-level components to visualize different chemical structures. So here I have different files. Actually, I can, maybe the smaller the better. So you can actually see some. There is a 693 atoms here. So I'm still working on this thing to calculate the cylinder, so I could have bonds and not just atoms. But this information is there, and you can see that here I'm using non-standard. Actually, this is nice. It looks like a kind of a DNA. So you can actually rotate it. So again, this is using the same techniques like I was showing earlier. So you can actually basically you have a dummy component, and you can programmatically, very much like with the star field, but in a star field the different spheres were located randomly, and here I have a special file format that I read from, and basically position different atoms accordingly. So this is an example of more practical applications. Notice also that this is actually a two-dimensional form, so you can still mix and match 2D with a 3D. So if you have a two-dimensional form, then for displaying 3D information, you need to have a viewport 3D component. So this is like a view into a 3D space. But this is actually quite handy because I can mix this 3D view with some traditional components that I'm using, like buttons. And also notice this that I'm using a custom FireMonkey style. So this is actually here. I have this stylebook component, and I'm using actually the style from one of the styles that comes with Delphi. It's actually users. No, it's actually users public and public documents and RAD Studio and 10.0, and I have different styles. So I'm using this transparent style, but I could also use some other styles, like maybe I can change it to air style to see how this is going to. So I have a different style, but in fact I like this transparent more. So let me actually clear this and load the transparent style, which looks very nice. So this is actually, you can combine also 3D applications with 2D. So in this, probably this is more convenient than doing this other way around. And you can actually see the actual implementation. So here I'm actually just changing the model based on these different components for rotating. And I'm loading, I have a whole implementation of how to actually extract this information. So those PDB files are just text files with a certain structure, so you just need to go through it, and based on this you can then position components in a different locations. So there is this molecule model, is just a molecule with a generic list of atom data, which is just a position in the space, and bonds. So I still need to render bonds. Okay, so that's actually that's an example of how you can mix HD with 3D. It's also possible the other way around. So I can create a new FireMonkey desktop application, which is a 3D application. If I want to use some controls that are 2D controls, I will need to use a component that is called T-layer 3D component. And I can use this to position different things like T-button. I can add to it, and it will have the behavior of a standard button. I can save it and add to this button something like show message hello, and this should actually display for me something in a 3D space. So I have a 3D form, but with a traditional two-dimensional controls mixed. So in this way you can actually mix and match the 3D elements with HD elements in the same application. Okay, so actually another great example of doing this is this FireMonkey 2. I have this, effects test. Actually, that's something that I've been playing with. That is quite surprising to me, that you can use the effects that are actually designed for using in a 2D applications, but they also have effect in a 3D application. So this is actually a very interesting demo that I have this viewport, and I'm adding to the whole viewport, I'm adding the glow effect. And the result is quite strange, because all the 3D components that are in the viewport, they will get this glow effect. And to make it more interesting, I'm actually using animations to change the different properties of the glow effect. So I have you can see in the object inspector that those properties that have attached animations, they actually show differently. So I'm changing this color animation, so I'm going through blue to red, and also in the second animation I'm changing the softness property of the glow effect. So at the end I'm going to have something more interesting. So you see that I have there is this glow effect. It's not documented and quite straightforward, but in this way you can make your 3D user interfaces even more interesting. So you can use effects that are typically used for 2D, but you can, if you attach the whole effect to the viewport, all the elements inside of the 3D viewport will have those, in this case, glow effect attached. And I can use animations to actually change the property of the glow effect, because it's just a component and you can programmatically change it. Okay, so I hope that you enjoyed this presentation. It was very difficult to compete with Ray Konopka and his custom FireMonkey components. Yeah, there are some resources. There's quite a lot of information online in a Glowacki. So also examples of building those cubes and using the new material model. So that's something I can recommend that you go and see for yourself. Okay, are there any questions? So have you tried to play with a 3D FireMonkey already? Some. So I hope that I demonstrate that it's a really big fun to do it, and you can actually, in a programmable way, you can use reusable components, and instead of doing this low level like in the Objective-C, you have to be low level, but with FireMonkey you have different benefits. You can be low level if you like, so I have demonstrated this on a low level demonstration, but you can also work on a higher level, so you can use reusable components like T-cube, T-sphere, and so on. And also you have the added benefit of this being cross-platform, so we are natively compiling for both Windows and Mac, and in the future for mobile devices from the same code base. And another thing is those controls that you use in programming, they can be interactive, so you can actually add functionality to the 3D user interfaces. When you click on a 3D object, something can happen. You can add an on-click, on double-click event to it. Okay, so that's it. If there are no questions, and thank you for your time. It's now coffee break, and we all go to the Ray Konopka session on the number 2. Thank you.